You need to be able to sketch a reciprocal function, that is, 1 over f of x for some other function f. In particular, later on, you have to be able to do this for rational functions of polynomials, so the thing on the bottom could be a polynomial up to degree 3. Let's start with a simple straight line section. I've got particular values for these points. What's the reciprocal graph going to look like? Well, the simplest thing we can do is get the value, the y value, the value of the function at each point, and work out its reciprocal. The y value of the first point is 1/2, so its reciprocal is 2. The y value here is 1, and 1 over 1 is still 1. Keep that in mind for later. The value of the function here is 1.5, which is 3 over 2, so the reciprocal is 2/3. The value here is 2, the y value, so here I'm going to have 1/2 as my reciprocal, and so on. Can you see what a smooth curve through these points is going to look like? It should look like this. You should get a nice smooth curve that looks like this. But what about the further out extremities of this graph? What are they going to look like? Well, here's a first look. We're going to explore this much more in the following videos. Notice this. As this graph gets bigger, being a straight line, it goes up to infinity. Well, as this line goes up to infinity, I'm dividing by a very large number, so I'm going to get closer and closer to 0. At this end, if I'm going toward negative infinity, I'm still going to be dividing by a very large, in this case negative number. So I'm still going to be approaching 0, but now on the underneath side, on the negative side. So this line in the middle, y equals 0, is actually an asymptote of this graph. The graph is going to approach y equals 0 at the extremities. Now that doesn't always happen, it only happens when the original graph goes towards infinity at either end. Then I'm going to have that. But there's another asymptote on this graph. What's happening here? Well, the original graph is 0 at x equals 2. That means I'm going to be dividing by 0. I can't do that. It's got a discontinuity. But as I get very, very close to 2, the bottom of my graph gets very, very close to 0, which means I'm going to end up with 1 over a very small number and end up very, very large. On this side, I'm going to be dividing by a negative number. The original graph is negative but very close to 0. So I'm going to be dividing by a negative number very close to 0, which is going to give me a very large negative value. And I'm going to get closer and closer to infinity as I approach x equals 2. So this line here, where the original graph was 0, becomes an asymptote for the reciprocal function. So let's think about this carefully. If the original function is increasing, then the reciprocal is actually going to decrease. If my numbers are going from 5, 6, 7 up to 8, I'm going to be 1 over those and I'm going to be getting smaller and smaller fractions. Where my original function is increasing, my reciprocal will be decreasing. And vice versa. If my original function is decreasing, then my reciprocal function will be increasing. If the original function is above the x-axis, then it's positive. My reciprocal function will also be above the x-axis because I'm dividing by a positive number. Likewise, anywhere my original graph is below the x-axis, means it's negative, and my reciprocal will also be below the x-axis. And this is something I noted as we went past earlier. The function and its reciprocal will intersect anywhere the original function was 1, because the reciprocal of 1 is 1. This will also happen at -1, because 1 over -1 is -1. So the original function and its reciprocal will intersect anywhere where the original y coordinate was 1 or -1.